What's up people, this is Vishal and I'm back again with another video. In this one we'll be writing a polyfill for promise. But before we get into the video, about 63% of you have not subscribed to the channel yet. So if you have not subscribed to the channel, please do it! And now, let's go. So before we jump into writing our own implementation for promise, let's look at this very simple promise statement over here. So we'll be dissecting the entire promise into simple problems and we will solve them one by one. Okay, so the first problem is getting this part working. So we have a very simple promise over here. We are instantiating the promise, we are passing the executor function, okay, and we are immediately resolving the value. There is no asynchronous things happening inside this particular executor function, and once the value is resolved, we have only one then function, and inside that then we are just capturing that value and console logging it on the screen, right? So let's start writing our own implementation of this promise. We will call this our own implementation as my promise, right? So we'll quickly create a class called my promise, okay, and of course for my ease of implementation I'll export this particular class out from here. So my promise is going to be exported out. Now inside my promise we will definitely need a constructor. And what do we need in the constructor? So constructor of promise is going to receive an executor function, okay, and this particular executor function executes immediately, right? As soon as we define over here, it executes. So we will do the same over here. So we will define a executor variable, executor argument over here, which will receive a function, and we will execute this particular function immediately. So executor. Now the executor function is called with the resolve function. So we will need to pass the resolve over here. Of course there is no implementation for resolve right now, so we will create an implementation for resolve, which is going to be an empty function for now. And our promise also needs a then function, right? So we will quickly create a then function, and this particular function is going to receive an input of a callback. Okay, so we will start solving this problem first, where everything is synchronous, right? So the executor function is doing a synchronous job over here, where it is just resolving 10 directly, and the idea is it has to execute immediately. So we are going to execute immediately, and we are going to resolve 10 from there. So whatever the value that is going to be resolved, that will be stored inside the resolve function as an argument. And now we need to store this function, now we need to store this value somewhere as the resolved data of the promise, right? So we will define a few variables over here, resolved data, okay, and initially it is not going to hold any value, so let's keep it like this, and we will write this dot resolved data equal to value. Okay, so we have resolved the data. Now when the executor's implementation is synchronous, so what do we do at that time? So it is synchronous, it is immediately going to resolve a value of 10, and we need to then immediately execute the then function. So the first our thread of execution will first execute this, and as soon as we resolve, it will go inside the callback function that we are executing. So basically the then function will be executed after the synchronous executor function has executed, right? So we have already set the resolved data as the value that we pass to the resolve. We will also need a variable over here which is going to be is resolved, which is initially going to be false, right? So we will also set this dot is resolved equal to true, right? Now we know that as soon as the executor function resolves something, we need to then start executing our then functions callbacks, right? So we need to start executing our then function callback. So we will need so inside our then we will check if this dot is resolved is done or not. So if this dot is resolved is there, means if the promise has been resolved, we need to execute this particular function, right? So we will execute this particular function, okay, and what is to be passed to this function? So this particular function is going to receive the data that has been resolved, right? So we will pass on that particular data which is stored inside our resolved data. Okay, so I think for this particular scenario where the executor is basically a synchronous implementation, that time I think this particular case would work fine. So let's quickly import our myPromise class. Okay, so we have imported our myPromise class, and instead of promise we'll write myPromise. And let's head on to our browser. We should see 10 printed on the console, and that's fine, right? So the first part where our executor only has synchronous operations over here, this particular implementation is working fine. Now let's proceed with asynchronous things. So what happens inside the promise? So if the executor is going to hold asynchronous operations, let's put a set timeout over here. Okay, so we'll put a set timeout of 1000 milliseconds, and inside my set timeout I'll resolve the value. Okay, now this is an asynchronous job which will resolve after a second. Now in this case, as soon as the executor function executes, it will see that there is a asynchronous job over here which will be handed over to the web API, right? So set timeout will basically move to the web API, and the call stack is empty now. Now if the call stack is empty, the next operation is ready to get executed, which is the .then function. Now inside our .then implementation, we have a condition over here: if this dot is resolved, which is obviously going to be false because our resolve function has not executed yet. It will execute after a second. So in this case, after a second, when my resolve is executed, we will not be able to execute the then function at that point, because the then's execution has already happened in the past when we were waiting for the set timeout to complete. Now how do we handle that scenario? So to handle that scenario, of course the then is gone now, so we don't have any context of then. So we need to store the context of then, so that when the resolve whenever the resolve is executed, that time we will use that context and resolve the value. Okay, so for maintaining the context, I'll write then function over here. So I've created another variable over here which is then function, and we will store the function's context inside this. So then function equal to the function that is passed. Alright, and let's also update this call to this .then function call to keep it consistent. Alright, so we are now executing this .then function. Now still we have not handled the scenario where the resolve is happening after a second, right? So after a second, when resolve executes, at this point now we know the context of our then function, right? So the then function, whatever the function that was passed at that point, we know the context of that. So we will now use this particular context and call our then function manually inside the resolve. Okay, so we will do this dot then function. Okay, we'll call this and we'll write this dot resolve data. Okay, so let's quickly see if that solved my problem. Let's hit a refresh, and after a second you will see that 10 has been printed. Now however, if I revert my code to go back to this state where the set timeout is not there, now my code will break, right? So the reason why is it breaking is because when the resolve is executing, at that point this .then function, in this case when the executor is holding synchronous definitions, that time the then function has not executed yet. So this .then function will not have any context at this point, so hence it is failing. So to handle that scenario, we'll put a condition over here: if this .then function, so this .then function, we will put a type check over here. Actually, if it is a function, we will basically call it. So if this .then function equal to function, that time we will just execute this .then function. Alright, I think this will handle both the scenarios now. Alright, so when the job is synchronous, it is handling that scenario. Let's recheck our asynchronous job too. So on the synchronous side of things, we will come back here, hit a refresh, and after a second 10 gets printed. So we have handled both the scenarios now where the resolve is working fine and our data is executing properly. Okay, so this is the basic implementation of the scenario when the problem when our promise is a very simple statement where we have a simple resolve, and we are doing one asynchronous operation, and we are not performing any then chaining. Now to perform then chaining, so our next problem would be to perform then chaining. So after then we will write another dot then, right? So let's do that now. So first things first, now to do then chaining, so inside from the then function I'll have to return a this, so that I can chain this dot then dot then dot then and so on, right? So I'll return this, so that I still have the instance of this particular class, and using that instance I'll be able to call the then function again. Okay, now when we are doing then chaining, that time we have multiple callbacks to execute, right? So we need to maintain that the order of those callbacks. To maintain the order of the callbacks, the best thing to use would be an array. Okay, so we will change this particular variable's name to let's call resolve chain. Okay, and initially this is going to be an empty array. Now we will use this dot resolve chain, and we will push the functions inside this particular chain, right? So all the callback functions, whenever we do dot then, we will push the we'll push the callback function inside this particular chain. Okay, so now we have pushed it. Now these conditions don't stand true anymore, right? So this condition, all of these are gone now. These conditions don't stand true anymore. So now we will change this condition. Now we know that we are receiving a chain of callback functions. So I'll just do this dot resolve chain dot length. Okay, so if the length is greater than 0, it executes. Now we need to maintain the sequence. Okay, so what happens is, let's say if I write dot then again over here, now that I've returned this from my dot then function, my editor will not complain about this kind of syntax anymore, right? So instead of now printing it onto the console, we will do return data into 2. Okay, so how this thing works is, in the first then, when the first then gets executed, we are getting the data as 10, we are multiplying it by 2, we are making it 20 and returning. Now whatever the data that we return from here becomes the data for the next dot then function. So now if I do a console.log of data over here, this should basically print 20, because we resolved 10, and the first then we multiplied it by 2, and then we returned that 20 into our final then statement, where we are just console logging. So we need to perform the same operation where we have a chain. Now we have to execute and pass the result to the next then chain. So the best way to do that would be our reduce, because the way I can say that is, we have a bunch of operations to be performed, we have a value given to us. Now we'll be reducing that value by passing it to multiple callbacks. So hence I'll be using dot reduce over here. So let's quickly change this. We'll write this dot resolve chain dot reduce. Now the syntax of reduce, very simple. We will have a callback function and an initial value for the accumulator. So for the initial value of the executor, we'll be passing our resolved data, right? So the reason why we are passing our resolved data, because whatever the data that we resolve from here becomes the input for our first then function, right? So quite straightforward. We will write this dot resolved data, and the arguments for these callbacks would be accumulator and the function, right? So whatever the callback function is coming over here, that is going to be there, and accumulator is basically going to hold the value of this dot resolve data, and whatever I'm going to return from this callback in the subsequent calls in the reduce, that accumulator will be updated, right? So let's quickly write the implementation. So we will write over here return fn of, so whatever the data that we are passing over here is getting stored inside accumulator, so we will be passing accumulator, and whatever I return from this function will be the next value of the accumulator for the second function. Okay, so I think we can make this one liner as well, so let's quickly do that. We'll make it one liner, of course. Okay, so this is my then chain execution. Of course, here we are still missing. We would still do the same thing over here as well. If the job is synchronous, that time when it is resolved, if we have a chain of multiple things, that time we basically do the same operation in this particular function as well. Alright, so I think this would solve our problem. So right now it should print 20 after 1 second. Let's hit a refresh. After 1 second it prints 20. Let's check the other scenario, so where we don't have a set timeout. Here it should still print 20, and which is happening right now, right? So we have solved two problems where we using only the resolve function. Now we are able to do then chaining, plus we are also able to handle both asynchronous and synchronous operations, right? So both the things are happening fine. So now let's proceed with our reject operations. This is going to be very similar and simple, so let's quickly write it out. So we have written resolve already, so let's write const reject equal to whatever the value, right? So reject also takes a value, right? So whatever the value that is given over here, that has to be rejected basically. Now here we'll be updating our executors argument list to pass reject as well. Now we will also create a similar data, similar variables for reject as well. So we'll write rejected data. Okay, we need a reject chain, and we will have is rejected, which is initially going to be false. Okay, and resolve chain will obviously be reject chain. So we have our variables ready. We kind of need to do the similar thing. So once the value is provided to the reject, we are going to set that to this dot rejected data equal to value. So we have rejected some value, and we will set this dot is rejected equal to true, and this part is kind of gonna be same for obvious reasons, right? So because once the data is rejected, again the scenario that I explained over here, it's the exact same scenario for reject as well. So we will do the same thing. Instead of resolve chain, we'll be writing reject chain. Let's copy this and update this. Okay, and of course here we are passing resolved data here, but we'll be passing rejected data. Okay, so this part is fine. For chaining our error scenarios, the rejected chain is basically for that we'll be basically using catch. Okay, so we'll be using creating a function called catch, and it will take a parameter function. Again, we need to do exactly the same thing, so we'll do that over here. We'll update our rejected chain in this case, right? So we'll update our reject chain. We'll be checking if the data is rejected, and here again reject chain. Of course this will also be reject chain, rejected data, right? Okay, let's quickly tally rejected data. Everything is same, everything is fine. Reject, 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 everything is fine. All right, now we need to quickly test this thing. So let's go to our index.js again. Instead of resolve after 1 second, I'll do reject after 1 second, and of course I need to update this with reject. Okay, right, so now we are going to reject after 1 second, and we are rejecting by saying let's say that's what she said. Okay, so we are rejecting saying that's what she said, and of course for getting the reject over here, let's not add any catch for now, and let's see what happens in our code. So we go here, hit a refresh, nothing happens because of course we have rejected something, but there are no handlers for that particular rejected data. So let's quickly add a dot catch, and this is going to take a function, and in this dot catch let's just return the error. So whatever the error that we got in this catch, let's just return the error, dollar error, and let's put a sad smiley over here. Okay, so yeah, so now we have a catch function to handle that rejected data. We are updating our data with a sad smiley because he got rejected, and now inside our next catch we will simply take the error information and console log it. Okay, so basically we are doing two things. We are doing whatever we did over here, added two functions into the then chain. Now we are doing the same thing with the catch chain as well. So we are going to add two functions over here where we will just say console.log of the error. On the console you can see after a second, once the data is rejected, after a second you saw that we are saying that's what she said, all right, with a sad smiley, which is getting added by our catch chain. So that basically solves our catch as well. So we did both then and catch, and it's working perfectly fine. Let's test another scenario where we don't have set timeout, where the executor function is synchronous. That time let's hit a refresh, it works perfectly fine, so we are good. Okay, now one more thing that I'll add in this, that would be the final thing that I'll be adding in this particular video, would be finally. Okay, so inside our finally function, now since this is a finally function, we will not be returning this because finally cannot have any then or catch chain after finally call, right? So finally is something which is the final thing. So in this scenario it is going to be quite similar. So what I'm going to do is, finally is something which will receive a function. I'll append this function or push this function in both the chains. Okay, so what would happen in that case is, if the data is resolved by using this particular reduce or whatever the reduce that I've written inside my resolve function, by using these reduces, it will basically execute finally at the end. If the data is rejected, it will use this particular reduce and execute the finally at the end. Okay, in both the cases we'll be able to execute our finally at the end, right? So let's quickly do that. We will write this dot reject chain dot push the function. So we have pushed it to the reject chain. We'll also push it to the resolve chain now. Oops. So we have pushed it at both the scenarios, and the final thing would be, let's put both the if conditions over there. Yeah, and I think we should be good now. Let's quickly test it out. So instead of console logging over here, we'll do return of the error from here, and let's write our finally call, and it is going to receive a function again and some data. This is where I'm going to console log my data. Alright, so let's update this then function as well. So instead of doing anything over here, I'll just return data. Let's multiply it by 2 again. Okay, so the ideal response when I'm passing resolve of 10 would be 10 into 2, which would be 20, then 40, and since finally is there at the end, which will be console logging it, so we should have 40 on the console. So let's quickly go to our browser, and you can see 40 is there. Hit a refresh, after a second 40 gets printed. Let's quickly check the synchronous behavior as well. So here, hit a refresh, 40 works fine, which is completely working. Okay, now let's test our reject scenario as well, where we are doing a reject, and again I'm gonna write that's what she said. We are already putting a sad smiley, and at the end this error should be executed by our finally. That's the only place we have written our console, right? So after 1 second you will see that's what she said. So let's hit a refresh. After 1 second you see the error chain has executed properly, and our finally function is also working perfectly fine. Alright, so yeah, so that's what I wanted to cover in this video. We covered then chain, we covered synchronous, asynchronous promises, we also covered the reject chain, and we also covered the finally. So one last thing that I want to do is, let's say my executor function is basically resolving something. Okay, so we are resolving 10 from here. Now inside my then function I will define another promise. Okay, so we will write new my promise, the same things over here. We'll have resolve, reject, of course a function definition. We don't need reject over here, let's get rid of it because we are only resolving from the executor. Now inside my then I'm defining another promise, and in this promise again I'm gonna set a timeout of the same thing. So let's copy this part and paste it over here. Now in this set timeout, instead of resolve I'll be doing a reject. Okay, and of course, so now what you will see in this is the executor, whatever the value that is resolved from here, that is accessible inside this, and I can use that value and reject it from here, right? And then inside my dot then we will receive some data. Or is it going to be then? Of course it has to be a catch, sorry, because we are rejecting. So we are going to receive some error, and we will do a console.log of let's do a chain again. Let's do a few more things. So we are going to reject with the same message. That's what she said. Okay, so we got the error message, we got the rejected value which is stored inside error value, error argument, and now from here we are going to return the error. We will write error. Okay, so whatever we got and whatever the data that we resolved from our executor, right? We'll use both of these and write 10 times. Of course I'm gonna put a sad smiley anyway. So yeah, so the output should be basically that's what she said 10 times. Right, so we have a catch over here where I'm returning something, and I'm gonna catch again and use that error again, and now we will be doing a console log. Oops, and we'll be console logging our error now. Alright, so ideally after 2 seconds we should have, that's what she said, 10 times to be printed onto our console. And let's set a refresh, and after 2 seconds you see that that's what she said, 10 times is basically getting printed onto the screen. Alright, so that's my implementation of a promise, and if you have any questions, just drop a comment in the comment section. Like and share this video with everyone who is aspiring to become a front-end engineer, and don't forget to subscribe to my channel for more such interesting videos in the future, and hit the notification bell to get notified about my videos whenever I upload them. So see you in the next one. Bye.